Alright, hi, this is Brandon Watson, and we're going to configure this tower. In just a second, I'm going to go over all the parts that we're going to be putting in. This tower is actually a Hewlett-Packard HP ProLiant server tower that I am in the process of rebuilding. So there might be a slight difference in what you see that you would think that it's a normal computer tower. But I'm going to install it as if I was installing hardware in a standard computer tower for the sake of this demonstration. Okay, we're going to talk about the parts of the system really quick that we're going to install. The pieces that I have available here. We're going to look at them one by one really quick. First, we have the power supply. The power supply is built in. This is a specialty power supply for servers that goes with this particular motherboard. It doesn't really make a difference as long as you know that you're using the right power supply for the motherboard that you're using. So it has instead of it having the 4-pin additional plug in addition to the main power plug, this has an 8-pin instead of a 4-pin. So it's a little bit different, but it's still the same concept. There's still a main plug and an additional plug. Next we have memory. We have memory pieces that we will use to install into the system. We have the hard drive that we will use as an example to install. Even though we're not going to be installing an OS, we're still going to put in a hard drive for the CMOS system to register. On the motherboard, since this motherboard is older, there is an expansion card here on this board that actually is the SATA controller, because the hard drive that I have here is a Western Digital 500 gig 7200 RPM SATA drive. I personally have come to love the IDE style, which hooks up with these ribbon cables that anybody in the industry has come to know and love. But for the sake of form, it has become really easy to use these. These are the SATA cables. These are the SATA cables that we've now used that plug into one end of the drive and the other end of the computer. Very thin, very easy to plug in. Personally, I liked regular ATA drives. It was easier to work with, because I happen to be a big fan of DOS, but that's another story. So instead of using the ATA, the IDE ports for the drives, we're going to use an onboard SATA controller, which is in here on the slot. And then we're going to use an IDE controller for the CD-ROM, which is not going to affect this project, but it is here for the sake of example. Okay, let's talk a little bit about the motherboard itself. The motherboard is pretty much the controller of everything. It sends the signals in and out. It controls the traffic from the processor to the hard drives and back. It does all the moving of the data into the appropriate places. There are certain things that have to be installed on here for it to work. First of all, in order for the most basic function of the computer to work, which is to turn on, this cable this cable is all of the plugs that go to the front of the case that control the switches and LEDs on the front of the tower that indicate traffic and indicate hard drive use and indicate signals for the computer to turn on and reset. There's a plug specifically made for this on this board where it goes in. The next thing that has to be plugged in is the power. Is this one. This is the main power cable, and it goes into the slot which you see here. Then you have this. This is the 8-pin specialty adapter. In standard motherboards and standard power supplies, there would be a 4-pin adapter. However, because of the difference in server technology and the need for extra power, this is an 8-pin, and it goes into this slot, which you can see here. It goes in here. Okay, the very first thing I'm going to talk about is the motherboard. The motherboard is already pre-mounted in this case, and of course there were washers underneath the installation to prevent the board from shorting out upon start. So that was pre-installed. The processor, along with heatsink and fan, is also pre-installed, which you cannot. There's just very difficult for you to see it. Here it is. Here's the processors underneath this heatsink with this fan. It was already pre-installed for the sake of this demonstration. Because the pins are so tiny, it's not a viable option just to take the processor off unless there is something wrong. So the processor is pre-installed. The motherboard is the device that routes all the traffic. It is the control system for the computer. Everything plugs into it, and everything goes in and out through it. So the first thing that you have to remember when you're installing it is the most basic function of the computer. It turns on. And we all know that we have switches on the front that control how it goes on and off. So, we're going to take this ribbon, which goes to the front of the tower and controls all the traffic to the front of the tower. It controls all the LEDs that indicate power, that indicate hard drive use, that indicate network use. On this case, I think there's one that indicates server load, which sometimes is different, or network traffic, which is different. So this cable plugs into this port on the motherboard, which I don't even know if we're going to be able to see it or not. If we really have to indicate what it is, we're going to plug it in here. Would you look at that? It looks like we have to debug our system. As you can see here, something has crawled up and died inside of this tower. Back in the day, when computers were about the size of this room and bigger, the problem remained with computers that bugs would crawl into the system, literally. Which brought to mind the expression debugging. So, this really puts the original meaning to debugging the system now that we've hooked up the front of the case controls to the motherboard, and we've debugged the system, we can now start hooking up the devices that hook up to the motherboard. Let's just start with the devices that are already on the board. Let's start with the processor. The processor, like I said, is already hooked up to the board. It is already in place. The heatsink, I believe, has even got a little bit of glue on it to hold it in place to the processor. So it is considered a bad idea to move the processor off of the board for instructional reasons, unless you are indeed in a complete laboratory setting where you are not worried about the result of the computer. In this case, I am going to rebuild the server at some point, so I prefer to keep the processor intact. So, on top of the processor you have a fan. This fan, this black fan here, spins at a very high rate, higher than I could ever spin it with my finger. It's almost to the point where if you look at it, you cannot see it. And will spin to keep the processor cool. Because the second it starts overheating, you can ruin your processor. Luckily, systems today have a system in check for checking heat of the processor. And if the processor overheats, the system will shut down safely to prevent damage to your processor. So this cable that's right here controls the power to the fan. So it has its own special port, which in fact is even the same color as the brown plug as you see here. Would go into this 4-pin adapter here. Another fan that's on the system is not on the motherboard, but it's this one right here. This is a system fan. It helps keep the system itself cool inside the tower. Because when the tower is completely closed, front case and all, it becomes very warm inside. So this moves air through the server in and out, and it keeps it running. It also has its own power adapter, which you see here. It is a flat plug with 5 pins on this one to differentiate from the other one's 4 pins since they take different power. And there's a port here labeled system fan, for you to plug it in right behind the processor, and you just push it in until it clicks. Now, it's great that the board has all this power in it. The power of these fans, the power of the switches. But where does the board get the power from? Well, the board gets the power from these cables. From these cables here. This is the main power cable that goes to the motherboard. This feeds everything that your motherboard will get. As you see, it's a very thick cluster of cables and a very big plug that has its own adapter here, as you can see. So by simply plugging this in here, and you slightly pull on the plug itself. Never pull on the cables, pull on the plug to make sure that it is snapped in. Once that's done, most computers in today's age have an additional plug. Remember, in standard computing, it is 4-pin. But because we're working on a server tower, because this is the only tower available for this demonstration, this is a specialty 8-pin plug, which goes in here. Okay, so everything on the board has power. Alright, now let's take a look at memory. Memory is an important part of the system, particularly with the operating system, as the operating system loads instructions into the memory so that it can run. A standard operating system today, particularly made by Windows, would require 4 to 8 gigs of memory as a recommendation, with the ability to install needing 2 gigs, meaning that Windows will not install if there is not at least 2 gigs of memory. With the addition of Windows 8, that number may have increased. So we're going to go ahead and install the memory. We have four DDR cards, 4 DDR slots, and 4 DDR chips. It is important to remember that although the sizes of the memory can vary when you install them, they must be the same speed. So these are all of the same speed. This one is a 256 megabyte. We're going to place it here, and then I'm going to attempt to move the camera. So I have slotted it here, and you would push it into the slots, and then from the corners push it down until it locks into place. Next, we're going to do this one. You just simply push it into the slots, push down, 1, 2. Next, this one's a 1 gig. You're going to put it into place, push down, 1, 2. Finally, the last chip. You're going to put it in the slot here. Once again, push down, 1, 2. Memory is secured, and if you should only tug on it slightly to check that it is secure, but once the arms click into place, it is safe to assume that your system is okay and that your memory is ready to go. Alright, now we're going to do the hard drives. This is a standard hard drive. This one's made by a company called Western Digital, which happens to be one of my favorite brands in buying hard drives. This is 500 gigabytes. It has 7200 RPM, meaning that it is 7200 revolutions per minute when it spins, which is probably the fastest that you're going to find it. It does have a SATA interface, which, if you can see it, plugs into this port here and the power into here. This is only the newer technology compared to that of IDE, where, if you can see it here, it was a ribbon cable that looked like this, that you would plug in here, along with power cable here, would create an installed hard drive when installed into the IDE port. Technology has moved along and no longer requires that we use those, and has moved on to these SATAs that you would take a cable flat edged like this and plug it into this port here. So there's your plug. Now you may notice that the power cable that you just saw me plug into that older hard drive does not look like this, which is true. Because this is an older power supply, because this is an older tower, we are using a different style connector. So the manufacturers of these hard drives will send you this. This is a power inverter or a power changer. Because it uses the same power for both, it just reroutes the pins into the appropriate places. So I would plug this into here, and then take this black edge and plug it in here. And that's what it would take to install a hard drive. But for form factor, we're going to go ahead and install this into the case. because the hard drive did not come with screws, and because there was no hard drive in here, we're going to go ahead and only install one screw. Now what you do is you put it into the case. I'm going to move in a little bit. What I have done is taken the hard drive and put it into the case by sliding it into this bay. This is the hard drive bay. This is where everything goes. So we're going to put it into here, and we're going to go ahead and install this into place. We're going to align it with the floppy drive more or less. Thus we can get it in line with a screw hole. Okay, got it in line with a screw hole. I'm going to take a hard drive screw, which is a very small screw, and screw this in. What I have just done is made the standard mistake. I let the screw fall into the system. Okay, I have successfully fished out the screw that I lost. So we're going to try this again. So, take the hard drive and just slide it into the bay and align it with the back of the other drive and line up the hole. Okay, close. Okay, I got it started so it's not going anywhere. And we just screw it into the bay. Now it's being held in by the one screw. Because of the design of the tower, it is very difficult to get to the other side and put in another screw on the other end. Ideally, you should put in 4 screws at all times. So now that the drive is in, we can show what's next. Now remember, the IDE ports I was telling you about are here. This is where these are the IDE ports that you're supposed to plug into drives to. The smaller one is made for the floppy. But we have a different expansion card. I hope you can see it. I just want you to see the expansion card. It's here. And on the back end here are the SATA ports. Because this board was originally made for an IDE setup, it had to be basically retrofitted. Not retrofitted, but post-fitted with newer plugs, such as SATA. So, I'm going to take the red SATA cable, and I'm going to plug it in to the port labeled port number 1 on the side of this card, and then I'm going to take it and plug it in to the port on the drive like I showed you a minute ago. Next is the power. Remember I showed you the specialty adapter. I'm going to take the adapter and I'm going to put it on so you can see. And I'm going to take the black flat end of it. I'm going to put it under the SATA cable for the sake of being able to get to the port. And I'm going to plug it in there. Okay. Hard drive is now installed. Okay, let's look at optical drives, like CD-ROMs. There is a CD-ROM bay here already installed. And obviously that's important. Nowadays, it's almost a requirement to use a DVD drive. Because a lot of games, a lot of operating systems, and a lot of other software is being distributed on DVDs. Why? DVDs are bigger than CDs. A CD-ROM can hold at max 750 megabytes or so, depending. A standard single-layered DVD can handle up to 4.2 gigs of data. And a dual-layered can handle 8.4, obviously. It's another layer of the same data. Of different data, the same amount of data. So it makes it easier for them to ship on that. And when compressed, that can hold exponential amounts of that 4.2 gigs. So the drive is already in place. The other external media that we've come to know and love and have shunned is the floppy drive. There is one here. We're not going to hook it up. The difference, cable-wise, is it has its own specialty power plug. The floppy does. It looks like this. It's four pins. It's a 4-pin adapter, as you can see. I hope. Yeah, it's a 4-pin adapter, and it is the standard and floppy for ages. Obviously, in today's world, you will not be setting up a floppy, especially with the existence of flash drives for moving data around quickly. The other piece of media that's in here that we're not even going to discuss is tape drive. That was for server technologies, and that has somewhat gone by the wayside at this point. So let's go ahead and hook up a hard drive. The differences in cabling for hard drives, like I said, the floppy has its own cable. The CD-ROM uses the same power cable that IDE devices were using before. It uses this kind of power supply, just like the old hard drives used to use. The CD-ROMs and DVD drives still use them. So you would plug that in here. Now, because we have a difference in IDE and SATA, typically you would always have, I was always taught to install a CD-ROM on the secondary IDE controller as a slave. So there was primary master, primary slave, secondary master, and secondary slave. I was always taught you should put the CD-ROM as a secondary slave and leave it that way all the time. That way, if you're going to add another drive, your CD-ROM is always last and your hard drives are in order in your CMOS. Ultimately, it probably doesn't make a difference, but that's something I was always taught. However, in this case, since we're not going to be using the IDE controller for hard drives, we're going to install this IDE cable into the floppy drive. And since the CD-ROM was the master, we're going to use the master cable and plug it into the slot here. Now if I was going to hook up the tape drive, I would bend this cable in and plug it in here. But because we're not going to use it, I'm not going to plug it in, because it can cause interference with the system, especially if there's no power hooked up to it, and I'm not going to hook it up. Alright, so now that everything's hooked up, you should always take a quick double check and look over everything. All your cables are tight, power here, power there, SATA there, power there. SATA cables strung in there, power cables on the board are tight, memory is tight, power supply is all set, everything's ready to go. Now the final step is to hook it up. So I'm gonna go ahead and I'm gonna take this cable for the keyboard, just for the demonstration, and plug it in. And I'm going to take the monitor cable that goes to this monitor here, and I'm going to plug it in as well to the back of the tower. See, the monitor is on. And now that I have just managed to unplug the power strip from the wall, like I have done many times before, I'm going to turn it on and reach for the power switch. Now, because this is a server tower, the fan starts up a lot faster before it gets in. So now we're going to take a look at the monitor here. It says ProLiant. I don't know how well you can see it, but there it is. There's your CMOS. And then there is your CMOS. So you see, it doesn't take that long. Without walking you through it and talking about stuff, it would take me 10 to 15 minutes to have done this. So I hope that this has been informative and that you have learned something.